Day 2. So we're still in Unit 6. As I told you, I'm not going to write equations and inequalities anymore. It's just going to be equations. We are on Day 2. Yesterday we spent the day doing properties, but really we hit hard distributing. Well, today we're going to really talk about combining like terms. There are a couple words that we need to define before we actually go into the combining like terms. And again, you have seen combining like terms before. Might not have been very long, it might not have been taught well, I don't know. I'm going to pretend you've never seen it. So let's start with some things that we need to know first. And we've talked about this word before, but variables. What are variables? What is a variable? Good, Brooke.
It's like a letter that represents any number.
Yeah. A variable is a letter or symbol that represents an unknown. And in math, that unknown is usually a number. Okay? So, letter or symbol, you're like, a symbol? Because most of us think of variables as A, B, C, X, Y, Z. Well, as you keep on moving up, you might see omega. You might see a beta. Like, for all I care, you could make the symbol a star. Okay? A variable is just something that is taking the place of an unknown quantity. Okay. Now, we mostly have seen variables before. But this is what we're going to really deal with and have been dealing with lately, are expressions. What is an expression? And we've been simplifying expressions this entire year. What is an expression? Go ahead, Braden.
An equation, isn't an equation without an answer?
Say it for me again. It's a what?
Isn't it an equation that isn't solved by how you're going to set it up against?
So, I hear what you're saying. An expression is not an equation. An expression and equation are very different because of one key thing. What does an equation have, Braden? What is there in an equation that makes us know this is an equation? Is he?
Like signs like multiplication.
Well, those are in expressions too. Brooke? An equal sign. We know it's an equation when there is an equal sign. So, if I'm saying there's a difference between an equation and an expression, what don't you think an expression has? It will not have an equal sign. So an expression is a mathematical sentence. Okay? And we're not talking about sentences with commas and periods and things like that. But in math, we have our own types of sentences. It's a mathematical sentence including mathematical operations, and we only know 4 of them. The 4 operations are addition, subtraction, multiplication, and division. So it has to have some type of operation, could, including mathematical operations, variables, and numbers. Okay? So an expression is a mathematical sentence that includes mathematical operations, variables, and numbers. The key, though, is it does not have an equal sign. As soon as you see something and it has an equal sign, it's no longer an expression, it's an equation. So an expression does not have an equal sign. Everything that we deal with for the next couple days will absolutely be expressions. So our distributing yesterday, those really were expressions. We were just simplifying them down. You do not solve expressions, okay? A lot of teachers use the words simplify and solve to mean the same things. They do not. You solve equations. You solve something that has an equal sign. You simplify when it does not. Is everybody with me? So if we are simplifying, that means we're dealing with expressions. Solving, we're trying to get something equal to something else. Okay, so we've got variables, we've got expressions. Let's get to the easy part. Okay, so we're talking about combining like terms today. You can put your pencils down for a little bit because we're going to do a little just show and tell. I don't know how to do this. Okay. So we're going to raise our hands. How many red markers do we have? I mean, I should see everybody's hands. How many red markers do we have? Kylie? 3. 1, 2, 3. This one is not red, therefore we don't count it with the red markers. Does everybody agree with that? Okay, let's try again. Shh, shh. Gonna confuse you now, Macy. I got you. Boom! Macy, how many red markers do I have?
3 still.
Why? But Macy, maybe you're confused. So I've got a black one in the middle, though.
Wait.
No, how many red markers do I have, Macy?
You have 3 red markers on.
Oh, so it doesn't matter that I have this black one in the middle?
No.
Oh, okay. So it doesn't matter that there's 2 here and 1 over here, right? Okay. I got you guys this time. I don't. This is. Shh, stop it. Ha ha! What, Brennan? How many red markers do I have, Brennan?
3.
No. You're missing these black ones, Brendan. Why do I have 3 red markers? Oh, there's 3 right here? But look. There's 1 red plus 1 black plus 1 red plus 1 black plus 1 red. Doesn't that mean that I have to add them all together and say there's 5 red markers?
No.
Wait, you're telling me that even though there's 5 markers, 3 of them are red, 2 of them are black, so I don't add them all together?
No, because.
Okay, wait, stop. This is important. It's going to seem silly, but this is important. So you're telling me that even though there's 1 red, 1 black, 1 red, 1 black, 1 red, you're telling me that these 2 ones right here don't affect how many red there are?
No.
You're telling me that if I ask for red markers, I can only count up the red markers?
Yes.
Oh my gosh. I'm going to bring this back when I make fun of you later. So, combining like terms. We can only combine things that match up. Just like The red markers can only get added. If I ask for red markers, we can only add up the red markers. The black markers didn't affect the number of red markers. You told me that's correct, yes?
Yes.
So we're going to use variables instead of names, okay? I prefer names. If I tell you how many black markers, well, there's a name. They're black markers. You can tell me, Mr. H, there are 2 black markers. Macy's like, I got this. I'm so good at this. I'm crushing it. Macy can tell me there's 2 black markers, okay? That's fine. But what if we take the name away? So let's say I have an R. The first thing that you need to understand is how many R's are right here. Just like yesterday when we did the distributing, how many, Kylie? 1. So there is an imaginary 1 there. Instead of calling it R, you know what I'm going to call it? 1 red marker. So this is now a red marker. I always name my variable. R is now red marker. Well, let's say I'm going to add 3R to that R. What, Braden?
4 red markers.
4 red markers. Because, why?
Because
Wait, wait.
you have 1 red marker plus 3.
Okay, so I have 1 red marker here. I'm going to circle that term. I circle my like terms. I have 1 red marker here. And then how many other markers do I have?
3.
How many?
3 red markers.
How many?
Positive 3 red markers.
Positive 3 red markers, because you need to include the sign with it. So now I do not worry. If I say, hey, we're going to add red markers. When we add the red markers, what are we ending up with? Well, we're still ending up with red markers. So I no longer care about the red marker part. So I don't care about the variable. All I care about now is my numbers. What's 1 plus 3?
4.
This is simplified. 1R plus 3R is 4R. It is easy. If you put names with it, it is easy. Well, so there's example 1. Let's try it a little bit trickier. I'm going to keep my street cred up. So there's 5 gangstas, and then I'm taking away 8 gangstas. -3 what, Noah? No, not gangsters. There's -3 gangsters, sir. No. Gangstas. Keep your street cred up, Noah. So, watch what we're going to do. We can only combine the gangstas. So, we combine 5G and what? Raise your hand. And what? Nevaeh?
-5.
Wow.
-8G.
Okay, so listen, stop. Stop. We know that our variable has to come with it. The gangstas are what we're subtracting right now. So that comes down. We no longer care about the G's. So 5 minus 8, Noah told me was -3. Gangstas. Or as Noah says, excuse me, sir. They're gangsters. Okay. So we good there?
Yes.
Okay. Remember how I said, listen, the marker stuff doesn't matter. I gave you a black marker, a red marker, a red marker. You said, no, there's still 2 red markers or whatever it was. And I said, I'm probably going to make fun of you. Well, let's find out. So we've got 3b plus 7 plus 5b. Cole, don't let me down. You're the man. Cole, what should we call the b's?
Big boys.
What are we going to call the b's?
Like the insect bees.
Oh, like the buzz bee. So we're going to call the bee bees. That's the...
You bet.
Okay, so Cole has said, stop, back to me. Cole has said that we are going to call the bees, you know, the insect bees, Mr. H. So the bees are bees. Okay, now here's my question. What can we combine out of 3b plus 7 plus 5b? What are we allowed to combine, Ryan? Just the bees. So what bees can we combine? This is those bees. What bees can we... Oh. What bees can we combine? Izzy? No. 3b. No. And positive 5b. Now stop, listen. We can only combine the like terms. Think about your red markers. Is this part of the bees that we want? There's no bees here. It's just a number. So when I combine them, notice how I'm circling and drawing arrows. If I'm doing something, it's probably a good thing that you do it too. 3 bees plus 5 bees are going to end up with bees. Bzz. Right. So there's my bees. Written as a letter B. 3 plus 5 is 8. So now I have 8 bees. What happens to the positive 7, Mr. Bush? Yeah, the positive 7 comes down. But notice how I boxed in the plus and the 7. Can I combine bees with a number? Bees and a number cannot combine. Just like you said, listen, Mr. H. Yeah, there are 3 markers, but I'm not going to say there's 3 red markers. There's only 1 red marker. Well, there's only 8 bees. The 7 is not part of that bee. Everybody still with me?
Yes.
Okay, let's do another one. Getting a little bit trickier. This is your answer right here. This is simplified. That's it. Negative 7 plus 5x minus 4x plus 2. Okay, let's go comic book style. We've got 5 X-Men, and all of a sudden we lose 4 X-Men. We've got a negative 7 and a positive 2. My question to you are, can I combine a negative 7 with X-Men? The negative 7 doesn't have the X. If they don't have the same name, they cannot get grouped together. They cannot be combined. So when I circle, negative 7 can be combined with what, though?
2.
What kind of 2?
2.
Positive 2. Negative 7 plus 2. This is where the adding rules come in. Well, they're different signs. We forget the signs we subtract. 7 minus 2 is 5. The bigger number is the 7. So it gives me negative 5. Questions on how I got negative 5. Now, we want the variable first. Anytime that we put these, I want you to have the variable out in front. So now we have positive 5 X-Men, which I'm going to do in a different type of grouping. So I circled these. I'm going to box them. If you've got different colors, use different colors. If you want to underline, hey, whatever works for you, but I like to know where my signs are. So now I have 5 X-Men minus 4 X-Men. How many X-Men do I have left, Kylie? If I start with 5, and we take 4 away, so 5, and we take 4 away, just 1. So there's 1 X-Men. You could put 1x minus 5. Do I need the 1 with the x? You don't need it. So it's just x minus 5. Like, all kidding aside, as long as you name your variables, you're fine. If it doesn't have a variable, in this case, the negative 7 and 2, those are called constants. Okay? Numbers in front of a variable are called coefficients. We're going to talk about that more tomorrow. But the numbers that don't have a variable is called a constants. Constants are like terms. I can combine constants. So as long as it doesn't have a variable, combine them. Okay? Because if I just gave you this problem, negative 7 plus 12. If I gave you this problem, which we kind of did 2 tests ago, what is negative 7 plus 12? Don't all jump at once. What is negative 7 plus 12? Ryan? 5. Negative 7 plus 12, different signs. We subtract 12 minus 7 is 5. Which number's bigger? Well, the 12. Those are constants. We were able to combine those. So think about it the same way. Numbers we are allowed to combine. Try this on your own. Raise your hand once you've got it. So let's go. So it says negative 7x minus 12 plus 42. You are simplifying. This is an expression. You are simplifying. We simplify because we can combine like terms. Variable out front. Always want that variable out front. Good. Good. No. A lot of you are having trouble with the addition part. Use your addition rules. There needs to be some kind of sign between this. Okay, so let's take a look. I always want the variable out front, okay? Usually in alphabetical order. So if there's an X and then a Y, well, say your alphabet X, Y, Z, so X would come first. I'm going to start off, I look at my first term, there's an X in there. So I'm going to circle it and try to find any other X terms that I can. Are there any other X-men?
No.
No. So my negative 7x is right there. Everybody with me? Okay. I need a different color. Do we have what we called constants? Are there just numbers there? Are there things without variables? Yes, negative 12 and 42 do not have variables. How do I know that? Because there's no letters or symbols next to them. So when I do this, I've got a negative 12. I've got a positive 42. We are going to combine those. When we combine those, we have to follow the addition and subtraction rules. So we circle and say, are they the same signs or different signs? Negative, positive. They're different signs. So we subtract. 42 minus 12 is 30. And some of you put negative 7x 30. Well, no, there needs to be some kind of sign. Which number is bigger once we forget the signs, Brooke? 42. The sign is positive. Put the plus with it. Can I combine x's and 30? No. This is simplified. That's it. Let's do one more. Just one more. And then I'll let you have your homework and we can go from there. Negative p plus 3p. Negative p plus 3p. You don't have to raise your hands. You don't have to raise your hand. We're going to go. In a problem like this, when you have variables without a number, you will need to place a number with them, or at least have the mathematical mindset to say, how many negative p's do we have there? Macy?
1.
Yeah, there's negative 1p there. Once I know there's negative 1p, now I can combine my like terms. So I've got pomegranates. I have negative 1 pomegranate, and then I'm adding 3 pomegranates. Well, we know that we're going to be left with pomegranates. Forget the signs, because they're different. Subtract 3 minus 1 is 2. The bigger sign is the positive. That leaves me with 2 pomegranates. Questions on this?